Hey there. You ever feel like chance is just this big, mysterious thing? Something we can't really pin down? Well, that's what we're going to tackle today. We are going to build a mental toolkit together, something that helps us understand and even measure the likelihood of things. And it all starts with a question I know you've asked before, right? I mean, we throw around phrases like 50-50 chance all the time. It's a total coin flip. But have you ever stopped to think about what that actually means? It seems so simple, but digging into that one little phrase gets us right to the core of what probability is all about. All right, so first things first, we need a solid definition. This is the first tool for our toolkit. We've got to move beyond just that gut feeling, you know? Let's get into what the pros, the mathematicians, really mean when they talk about chance. And here's the absolute key: long term. See, probability isn't some crystal ball for predicting a single event. There's no way to know if the very next coin flip is going to be heads. Nope. It's all about the pattern, the big picture that shows up only after you do something over and over and over again. And this is so important to get. If you just flip a coin, say 10 times, the results can look super weird. You might get a crazy streak of heads or a ton of tails. And that's because in the short run, chance is kinda lumpy and unpredictable. It doesn't look fair at all. And honestly, it can totally throw you off. Let's actually look at an example. So after just 10 flips, maybe you get 7 heads. That makes it look like you have a 70% chance of getting heads, right? But watch what happens. You keep flipping. At 100 flips, you're maybe at 53 heads. Okay, that's getting a lot closer to the truth. And if you had the patience to do 10,000 flips, man, that number would be hovering right around the 50% mark we all expect. All that short-term weirdness just smooths itself out into this beautiful, predictable pattern. And this amazing idea actually has a name. It's called the law of large numbers. This is a huge piece of our toolkit. It's basically a guarantee that if you just do something enough times, the chaos will settle down and the real, true probability will reveal itself. Okay, so we've got our definition down. Now we need the blueprints, right? The core rules that make the whole thing work. And you'll love this. It turns out there are really only 2 fundamental, absolutely unbreakable rules for all of probability. And here they are, side by side. First up is the range rule. Super simple. A probability has to be a number between 0 and 1. Think of it as 0% to 100%. You can't have a negative chance of something happening. That makes no sense. And you can't have a 110% chance either. It's a closed box. Then we have the sum rule. This one says if you take every single possible thing that could happen and you add up their probabilities, you have to get exactly 1. Not 0.99, not 1.1, exactly 1. So let's make that real for a second. A probability of 0? That means it's impossible, flat out. Think about rolling a 7 on a normal 6-sided die. There's just no side with a 7 on it, so the probability is 0. It cannot, will not happen. And on the flip side, a probability of 1 means it's an absolute certainty. It's guaranteed to happen. Like, what's the probability you roll a number between 1 and 6 on that die? Well, it's 1, because you have to land on one of those faces. There are no other options. This is actually a great example of both rules working together. The event is certain, so its probability is 1, which is also the sum of all the possible outcomes. All right, we have our definition, we have our 2 unbreakable rules. Now we need the raw materials to actually build something. And to calculate any probability, the very first step is to map out every single thing that could possibly happen. And this map of all possibilities has a name, of course. We call it the sample space. It's just a complete list of every single unique outcome. So for our die roll, the sample space is just 1, 2, 3, 4, 5, 6. That's it, the whole shebang. Okay, so we have this big map, the sample space. But usually, we don't care about everything at once. We're interested in something specific. And that specific thing is called an event. An event could be super simple, like rolling a 3, or it could be a whole group of outcomes, like our event rolling an even number, which would be 2, 4, 6. And this leads us to a really powerful but really simple formula. Now, this works when every outcome has an equal shot of happening, like a fair coin or a balanced die. In those cases, the probability is just a simple fraction. You take the number of ways your event can happen, and you divide it by the total number of things that could happen. Let's actually plug in the numbers with our die roll example. So our event is rolling an even number. How many ways can that happen? Well, you could roll a 2, a 4, or a 6. So that's 3 ways. And what's the total sample space? We already said it's 6 possible outcomes. So we just divide 3 by 6, and what do we get? 0.5, or 50%. Hey, look at that. We just used math to prove the 50-50 chance we were talking about right at the start. Okay, we have all the pieces on the table now: the definition, the rules, the sample space, the events. Let's assemble them into our final tool, a full-blown probability model. And what is a probability model? Don't let the name intimidate you. It's really just a list. It's a complete list of every single thing that can happen. That's our sample space. And right next to each one, it lists its specific probability. That's it. It's the full picture of what can happen. And you know what's cool? You can instantly check if any probability model is legit. You just use our 2 unbreakable rules as a checklist. Step 1, look at all the probabilities. Is every single one between 0 and 1? Check. Okay, step 2, add them all up. Do they total exactly 1? Check. If you can say yes to both, boom, you've got yourself a valid probability model. So why go through all this trouble? Well, once you have a model, you can start making some real judgments. For example, in statistics, there's a handy rule of thumb. If the probability of something is less than 5%, or 0.05, we generally call that event unusual. It doesn't mean it's impossible, not at all. It just means it's unlikely enough that if it does happen, we should probably pay attention. So think about where we started. We went from a simple question about a 50-50 chance all the way to building a complete mathematical model. But here's the kicker. The exact same ideas we just talked about, the law of large numbers, those 2 simple rules, mapping out all the outcomes, these are the absolute bedrock for predicting the weather, analyzing the stock market, running medical trials, you name it. Sure, the math gets way more complex, but the fundamental logic, the toolkit we just built together, it's exactly the same.